So in the case of mass moth examination, what you're going to do is basically this is done in the commercial seed or industrial seed production. You're going to take around 10 to 30 groups of moth samples. Then after the oviposition, then the moths are crushed at around 10,000 rotations per minute so that your pebrine spores are completely separated from the tissue. Material is filtered, and again you're going to see under the 600 magnification under the microscope. Same procedure is followed. Only thing is you're going to use your like 10,000 rpm to separate the pebrine spores. So healthy pebrine infected, this is how it is going to be. Then you're going to see after centrifugation, you're going to see the like observe under the microscope. So the identification of the pebrine spores, you can see them as shining oval bodies under the microscope. Then you're going to surface sterilize the eggs, basically, especially wherever the sheets on which the eggs are going to be laid. And whenever there is any kind of sheet or card having poor egg layings or dead layings, they have to be soaked in 2% formalin for 5 to 10 minutes and then again reused in case it is necessary. Of course, all the details regarding the egg, the batch, the name of the grainage, the hybrid combination, all of it is taken into consideration. Loose eggs are going to be sterilized with around 0.5% of bleaching powder, or hypochlorite, and then assessed. Unfertilized, spoiled, diseased eggs, all of these are removed and then in disinfected as well. And what are the characteristics? You have to see good layings. What are they? Basically, minimum of eggs, 300 eggs, and there should not be any kind of piling of the eggs. The eggs are supposed to be in a single layer, side by side, in fact. And maximum number of disease-free layings are considered as good. For a multi-volt and hybrid seed, again, non-pigmented, non-hibernating, should hatch after 10 days. Acid treatment is not required. And then you see the eggs cannot be stored for more than 20 days in 5 degrees Celsius. For bivoltan and multivoltan, male and female respectively, they are used for production of hybrids. Again, you have to separate the sexes at the moth level itself so that you can produce the hybrids. For multi-volted hybrid seed, you can see that the eggs are pigmented, hibernating, and they do not hatch after egg laying naturally. Acid treatment is required to make the eggs hatch after 10 to 11 years, 10 to 11 days. And these eggs can be stored up to 6 months only if they're in the temperatures 2.5 to 5 degrees Celsius. So if when you see that, if you summarize this lesson, you need grainages to produce pure and hybrid seeds. And at the center, you have the commercial egg production. Basically, they have a direct link to the seed rearers. So you get, end of the day, you need to get a good quality seed. And then you need to synchronize the moth so that, both male and the female are the right time for mating, and at the same time, so you have around 9 to 4 days of spinning. Pupal age varies between according to the races and according to the seasons. Unhealthy, crippled, injured males are rejected. Only healthy males are selected for mating, and then each male can be used for 8 times mating. Egg production is very important, and after they couple, you have to decouple them. That is also important. And then you have to make them pass urine. Later, moths are placed on the egg carts. They are covered individually with cellulae or the moth funnel as such. And then loose egg preparation is used for industrial egg production at a very large scale. And then oviposition, you have to have a conducive temperature of around 23 to 25 degrees Celsius, and 80% humidity is very much necessary. Pebrine is a trans-ovarially. That means it affects the female moths present inside the the reproductive system of the female. And at the same time, usually the spores are present in the gut of the moth. So infected moths transfer the disease through eggs to the next generation. So yes, that is a very important reason why you need to remove those moths which are affected by pebrine disease. And egg surface should be washed, surfaces disinfected to remove the stains, surface contamination. So, and then total number of eggs which are laid by one single moth is called as the single or one laying. So this is all about your unit 7. Now let us unit 8, that is Now let us just have a look at egg preservation, hibernation. So what is it that we have to see? How are we going to preserve the eggs? We have already seen a little bit of it in the previous chapter. Now in this, we are going to see that certain times the eggs, especially the bivoltins and some of the univoltins have diapausing, that is hibernation. So eggs of non-diapausing and diapausing, they have to be handled accordingly. So how are you going to preserve? So high quality will hibernate. Univoltine eggs after oviposition, if they are left without any treatment, go undergo hibernation or diapause. They become diapause and without hatching. Bivoltine, if they are incubated at a high temperature, become hibernating or black eggs. So then they do not hatch for the second time in the year. What are the two different types of eggs? We've already seen, had a look at it. Is diaposic, non-diaposic eggs. And after the oviposition, again you need to process the eggs. Usually univoltine, other that is hatching for once, are diaposic eggs. Multivoltine eggs are not diaposic. The industrial or the commercial eggs are usually hybrids of both the uni and the bivoltine, and they are non-diaposic in nature. How is it that you're going to classify or handle these eggs? There is a hormone which is actually involved in making these eggs, undergo inhibition of the embryo development. And this hormone is going to be, its effect of it is going to come down or neutralize in the cold temperature. So what happens is that causes the eggs to get activated. That is why in the high temperature, what happens is they become hibernating or black eggs. So cold temperature is the key reason. So you have to put the eggs in the cold temperature treatment so as to break the diapause phase altogether. So eggs laid in any season can be preserved, hatched as required following the spring, during the next spring, that is. And handling of this eggs is very much necessary. Accordingly, you can actually see that what do you call it prevent the diapause and hatch them according to your time and convenience. So depending upon the nature of the eggs, hatching of the eggs can be controlled, and conditions required for maintaining this is different kinds. So how are you going to handle the eggs? So when it is multivoltine, they are the non-hibernating eggs. So they, after laying of the eggs, after 10 days, they hatch. If the hatching is delayed by any chance, eggs on the second day of laying should be put for preservation at around 5 degrees Celsius, 75 to 80% humidity for at least 20 days. So this is the minimum time, and during this period, eggs can be released for the incubation on any day. Now, when it comes to the bivoltine eggs, these are usually hibernating in nature and they do not hatch. If at all they are not hatching in 10 to 11 days after laying, they have to, that means that it is undergoing diapause. So they have to be hatched using artificial treatments and depending upon different kinds of methods. Now, how is it that you're going to preserve the eggs produced in the spring? So in about a week after, when the embryo actually goes into the stage of diapause, egg color turns slightly yellow after it is laid. 36 to 48 hours, what happens is it changes to reddish brown color and then subsequently becomes darker. After 4 or 5 days, egg is going to have the inherent color of the parent variety. So during this period, what happens is embryonic development is quite a lot. So respiration is also quite a lot. So you should take care of such kind of eggs at this particular stage. So what should you do? You should not subject them to shaking, crushing or rubbing the eggs together or any kind of such kind of movements. Eggs should be kept in well ventilated rooms and a constant temperature of 24 to 25 degrees Celsius is given. Relative humidity of 75% is given. And then you have to see that 25%, 25 degrees is given the temperature. About 30 or 30 degrees Celsius is harmful. Lower also causes or a break in the diapause. So that is also not safe. And accordingly, you can preserve this temperature or preserve the eggs for around 52 to 60 degrees Celsius at around 23 to 25 in the summer. And according to that, If you get up to 80% hatchability from the eggs, if at all they're preserved at 25 degrees Celsius, you can preserve them from 10 to 210 days. So optimum humidity is always 75 to 80%. And when it comes to preservation in autumn and winter, again, they're still in diapause. So there's no much change, if at all, in the temperature, then they can be preserved. And you can expose the eggs to a lower temperature, 7.5 to 5 degrees Celsius or lower, and follow the previous step again. At the end of Jan or beginning of February, what happens is diapause is terminated at around 5 to 7.5 degrees Celsius. Embryos increase in length, head lobe is quite wide open, and 5 degrees Celsius, if you keep any longer, then you have to terminate the diapause and it becomes unviable. That means the eggs cannot be used for hatching. And intermediately, what you can do is you can have a just to ensure the survival of eggs, they are allowed to develop one step by step conditioning. So 15 degrees Celsius for a few days. Then again you follow the step 5, and then the eggs can reach the longest embryo stage just one day before appearance of the neural funnel basically. Then the eggs are kept at 2.5 degrees Celsius till the time of incubation. So you can just do this particular step. In the subtropical or the tropical areas, what happens is atmospheric temperature is quite high. So at this time, it is too high to break the diapause even during the winter. So all the time you need a centralized AC conditions wherein the temperature is maintained at 25 degrees Celsius throughout the year, and you should have a cold storage room wherein you can have a temperature ranging from 5 to 10 degrees Celsius. And then you can change the temperature accordingly so that you can follow all these steps. Now then preservation of the eggs, especially in autumn, what can you do? During this period, that is from October to March or April next year, you need low temperature and you need preservation so that the diapause can be terminated between 2 to 3 months. So what can be done? Preservation at 25 degrees Celsius within 20 days after egg laying. Then you have to slowly or gradually lower the temperature. 20 days first day, then 15 days for the next 5 days, and then much lower. And then after this is preserved for a month in such a manner, they are kept in cold storage, 5 to 7.5 degrees Celsius or 2.5 to 5 degrees Celsius for hibernation. Again, what are the hibernation schedules that you can see? Physical chemical stimulants that is necessary for artificial hatching are acid-treated hibernating eggs. They can be utilized up to 10 days or up to 1 year at any point of time. So you have physical stimulants that are present, that is basically temperature, low temperature, dipping in hot water. And you see electric shock, rubbing with a brush of feather, high atmospheric or pressure, ultra high frequency vibrations exposing to sunlight, UV rays or short UV rays exposing to oxygen. And of course, chemical stimulants that as the HCl, HNO3, that is the nitric acid, sulfuric acid, aqua regia, which is a mixture of both sulfuric and nitric acid, acetic acid, all of these are your chemical stimulants that are present. And you need to use dilute HCl of a specific gravity because usually HCl is one of the strongest of the acids that is present along with that of the sulfuric acid. So you have how to prepare 1 liter of dilute acids and based on the different kinds of specific gravity. This is given amount of water taken, amount of acid taken. So you're going to get this particular specific gravity that is 1.150. If you want 1.10 HCl gravity, you need to take 330 ml of water and 667 ml of acid and so on and so forth. How are you going to calculate it? Basic chemistry, you must have learned even in your intermediate. That is required concentration of HCl is equal to required specific gravity minus 1 into required HCl in ml by available specific gravity. You already know the volume of the HCl that you're taking, volume of the water you're taking, specific gravity of the HCl is also already known. So accordingly, you can calculate. And 1 is the specific gravity of water over here. So accordingly, you can do it. And for formalin treatment also, you have this particular for acid treatment, it is a prerequisite. That is 2% formalin. So a required percent, you want 2% formalin. So what can you do? The commercial formalin. Commercial formalins, all the details are already known to us. They give the concentration, they give the strength, that is the concentration, volume, and if at all there is any kind of water in it. Usually there's no water, so they're going to give you the concentration. They're going to tell you the molality, they're going to give you the weight, and they're going to give you the volume that is present, and also the molality, no, molarity, everything is given. So accordingly, you can calculate the required percentage, which is commercial formula minus required formalin strength by the required strength that we need, which is 2%. So this is going to help the eggs to be fixed onto the card, especially during the acid treatment. And after the time is like, lapsed, that is after some time, the eggs are washed in water. So in summary, if at all you're going to see this lesson, it is like in silkworm rearing, the eggs are supposed to be like, in case you want to store them, not they are supposed to be stored. In case you want to store them, there is like, you have certain ways. So eggs are of two types: diaposing, non-diaposing eggs. In the diaposing eggs, it's the hormone that is responsible for the embryo development inhibition, and this effect is going to be neutralized by cold water. And in about a week, the embryo enters a state of diapause. Eggs are slightly yellow. September through October, again diapause, no variation as such. And in autumn, it is going to be like, for ready for rearing. They are called as the autumn eggs. They're supposed to be hatched in the following spring. Acid is used to treat the eggs so that the diapause or the hibernation is broken. Dilute HCl or specific gravity is prepared for treating eggs. This is all about your egg, like, preservation. When it comes to the acid treatment of the silkworm eggs, what are you going to do over here? We have already seen we are going to use formalin, we are going to use HCl, we are going to use sulfuric acid, we are going to use aqua regia, as well as, different kinds of acids. So what is it that we are going to do over here? So in diapause, as such, it is the effect of overcoming any kind of unfavorable period, hibernation. So we are going to break that hibernation as such. And for the silkworms in the temperate region, this is going to like, be easy because they do not diapause. Whereas, in the tropical, there is there. Then acid treatment, the phenomenon of diapause is environmentally, physically, genetically controlled. So acid treatment is just a method to change the physiology by blocking certain activities and inducing several new biochemical reactions. So they are going to be referred as the diluting, hibernating or bivoltan eggs, whereas the non-diapause ones are known as the non-hibernating or multivoltan eggs. System. So what is it that is happening in the artificial hatching? So in the artificial hatching, if at all you take the like, diaposing eggs, you do not do any kind of treatment as such. So the eggs do not hatch on incubation alone. So what is it that you're doing? You need to give the eggs certain physical and chemical stimuli. There are different methods that can be done. So immersing the diaposing eggs, that is the hibernating eggs, in HCl is one of the best and most widely adopted technique that is there, especially for immediate hatching. So what is it that you're going to do? To shift it from like, the diapause, like, for the hibernation to stop and the eggs to hatch completely, what are you going to do is you're going to take either HCl or nitric acid or sulfuric acid, concentration of the acid at a percentage that is given, at saturation especially. So HCl is 40%, nitric acid is 100%, and sulfuric acid is also 100% with a density at a particular temperature, which is 20 degrees Celsius. So how is it that you're going to do? Like I already told you, required concentration of HCl by the end, you're going to take the specific gravity of water as 1. You have different kinds of problems over here that's being given. And if at all you're going to do, after this, you have to take and perform formalin treatment of the eggs to enhance the adhering efficiency, that is sticking efficiency. The mother moth, while oval position, provides a thin film of gluing substance which is secreted from the glands. So this is going to also help in like, enable the like, the eggs to stick to the egg card. But then after acid treatment and subsequent washing in water, it is going to be loose. So to overcome this, what is going to happen is prior to acid treatment, they are soaked in 2% formalin solution because that glue which is secreted by the mother is going to be washed out. So when 2% formalin solution, you are going to dip these egg sheets or the egg cards. Then formalin acts as a fixative agent. So the eggs are still stuck to the egg sheet as such, or the egg card. So what happens is it is going to be used, and this will actually help in the surface sterilization of the eggs against different diseases causing pathogens as well. So surface sterilization is done. So it's a two-pronged approach, and it is going to be very useful. And then once this is done, they're directly subjected to drying or subjected to washing in water. And then you're going to go for the acid treatment. And what are the common methods of acid treatment? You have two methods. One is hot acid treatment, cold acid treatment. Hot is like, at around 46 degrees Celsius, you're going to dip. Specific gravity of 1.075 is necessary. And before heating, the specific gravity of the acid is first adjusted to room temperature. HCl is not directly heated because it is very dangerous again. So accordingly, acid is taken into the glass tube, and then accordingly placed in a treatment bath, which is usually water, and then it is treated. After treatment, eggs are washed in the water. Hot acid is treated after 24 hours. Otherwise, the eggs cannot actually uh, withstand that kind of treatment. Cold acid treatment at room temperature, no heating of the acid, carried out at around 23 to 30 degrees Celsius after the 24 hours of position. Treatment is on the first embryo stage itself. And again, HCl is 1.110 specific gravity, 15 degrees Celsius temperature. This is used to treat. And first, you have to do that 2% formalin treatment, which is going to act as a fixative. And then you have to proceed with the acid treatment. If at all there are any loose eggs, you can do a similar way, wherein the eggs are washed in water, dried on a smooth cloth. How are you going to stop the acid treatment? Generally, not exactly useful or advisable. And if it is inevitable, then the eggs are kept at 5 degrees Celsius for 5 days, up to 7 days at 2.5 degrees Celsius. And then this process can be carried out later. The eggs are kept at 15 degrees Celsius for 2 hours and slowly brought to 2.5 degrees Celsius. So then hibernated eggs are acid treated to prevent this diapause. And eggs are stored at 5 degrees Celsius, but not for more than 3 days. Cold storage is again of two types. So whenever there is this like short-term chilling, 25 degrees Celsius, 75 to 80% humidity is maintained, and then only up to 30 to 35 hours at 25, so that you have the spoon head stage, then preserved at 5 degrees Celsius with 75 to 80% of humidity. After this, you can store the eggs. Then after for hatching, the eggs are treated with HCl for 5 to 6 minutes. Eggs are washed in water to remove all the traces of acid. So this can be made to hatch after 45 to 60 days after laying. Long-term chilling, of course, 25 degrees Celsius, the eggs are preserved for 40 to 50 hours. Then 5 degrees Celsius with 75 to 80% relative humidity for 50 to 70 days. And later you're going to get it to 15 degrees Celsius. At this stage, what happens is, while they're releasing, they're going to turn from yellow to brown color. And then later, they are going to be treated with HCl for a specific gravity of 1.10 at 47.8. So you're giving a hot treatment for 5 minutes. After the treatment, eggs are washed in water to remove all the traces of acid. These eggs can be made to hatch in 60 to 80 after they are laid. Transportation. So from the grainage to the rearing center, you're taking them. During this period, you need to see that transportation, friction, air, light conditions, saltiness, all these should be avoided. So you're going to put them in a good, so that you have a good hatching and good quality of the cocoon crop that is being yielded. So early morning or late evening, you have to transport. Eggs should not be transported during the hot hours or in the raining weather. The eggs are loosely placed in a perforated wooden egg carrier or a perforated paper cover, and then specifically made egg boxes can be used for transportation. Incubation, of course, for proper healthy development of incubation and uniform hatching by golden eggs, optimum light temperature humidity is maintained. And then you have to see that hibernated eggs are released for incubation through intermediate temperature. After release, they have to be soaked in formalin for 5 minutes, washed, dried before incubation. And then you have to have that brushing frames, incubation room, thoroughly disinfection should be done, and proper incubation should be done so that larval health is going to be there. So, and then, you can slowly, to get the maximum hatching, optimum incubation temperature from 2.5 to 5 to 7.5, you have to actually slowly raise the temperature so that it reaches optimum temperature for hatching slowly. During incubation, also 75 to 80% of the time, this humidity is maintained. Then eggs that are incubated as above hatch in 10 to 12 days. 2 days before the hatching, egg again the color becomes lighter in shade with a distinct dark spot. Then the head, this is known as the head pigmentation stage. And 1 day before hatching, the eggs turn bluish. So this is again known as the body pigmentation or blue color or blue egg stage. So again, these two stages are very, very sensitive to humidity, that is low humidity. So that is why 75 to 80% of humidity should be maintained always. To obtain uniform hatching, eggs are kept in the dark at the head pigmentation stage 1 day before. Then darkness arrests the hatching of the developed eggs, facilitates lagging embryos to reach that hatching stage. And after 2 days, when the larvae are out, eggs are exposed to light. This ensures uniform hatching. And you can also refrigerate the blue eggs in the newborn larvae. Hatching of the eggs under incubation can be delayed, if any, by refrigerating them in the blue egg stage for 2 to 3 days. And you should see that care must be provided so that you have around 75% to 80% humidity all the time. Newborn worms can be refrigerated at around 5 degrees Celsius for 2 to 3 days, but not really necessary. So to summarize this whole lesson, you're going to see that diapause is the unfavorable condition to be to pass over it. So it's basically hibernation. It is environmentally, physiologically, genetically controlled. And then to shift from the non-diapause to non-diapause type, you need to see that the incubation time is changed, and the temperature, humidity, such conditions, if they are changed, then diapause to non-diapause stages can be reached. Acid treatment gives good results basically to see that the eggs start hatching. And then you need to soak them prior in formalin so that the eggs stick to the egg cards, egg sheets. And then after that, acid treatment is done. Usually you use HCl of a specific gravity, and you have two types of treatment: acid treatment, which is hot acid treatment, and the cold or acid treatment. That is short term, and long term chilling is also there. Then you have how to transport them is also given. And then the period of transportation, you have to take care that light, saltiness, humidity, high temperature should be avoided. So for healthy development, uniform hatching, bivoltine should be incubated at optimum light temperature humidity. Hibernated eggs are released for incubation through intermediate temperature, which is around 15 degrees Celsius. Now, when you look at the byproducts that are present, what are the different types of byproducts that are going to come for you, basically? So what is it that you're looking at? So, and what are the commercial value of all of these byproducts? So any kind of industry, you name it, you will have industrial byproducts. This, in case you are trying to, see that, if you need something which is you need your industry should be profitable, you need to make sure that the byproducts are also going to have some kind of a use. In sericulture also, you need byproducts. So normal way is that any kind of agriculture, of course, we have many byproducts. Depending upon the circumstances, you can start an industry and see that, you get a good income even through the utilization of the byproducts. So, and here you have all four activities, which is mulberry cultivation, silkworm rearing, granate, silk reeling, and in each particular activity, you have many byproducts. So, mulberry silkworm is exploited so far only for silk production in India. Sericulture industry, we need to keep keep it alive in India because, of course, we have there is a perennial need for silk in our country. As long as there are ladies in this country, we have perennial need for silk basically. So, what are we going to do with the byproducts as well? So, a substantial quantity of this mulberry leaves that are not used, unwanted silkworm larvae, moths, pupae, silk, all of these are going to be your byproducts. So, what are they? Waste cocoons, first thing. In waste cocoons in sericulture, this cocoons two purposes, that is reeling and that is primary and most important commercial product of the industry. And the other is the grainage, wherein egg production activities there present. So the cut cocoons, pierced cocoons are usually used as the raw material for spun silk industry. And the industry, what happens is whenever you use mulberry leaves that are there, that are pierced, cut cocoons, the floss that is coming out, and whenever there are any kind of double cocoons or black or melted flimsy stained or urinated cocoons, then all these are your byproducts. So around 28 tons of bivoltine or multivoltine cut or pierced cocoons, if at all they are present for disposal, you have a tender notification basically, that is your NSSO, National Silk Consortium, that one basically. So you have quite a lot of wastage. You cannot call it wastage, you call it byproducts. So apart from this, bulk of the waste cocoons, registered seed producers, that is the RSP, government model grainages, contribute to about 80% seed production in India. So 28 tons of bivoltine or multivoltine wastage is seen, and then 80% of the seed production is is used, and it is only 2% of the cut or the pierced cocoons that are actually being used for making handicrafts. So you have a lot of potential in case you know what to do with this kind of wastage or byproducts. So around 1 lakh disease-free layings, that is for the production of 1 lakh DFLs. Around 4.25 lakh bivoltine cocoons are required. So you're seeing 3.25 goes into wastage, out of which only 163 cut cocoon is obtained. That is the kind of byproduct production is that is being seen for the production of the top silk. So silk protein, sericin, fibroin, these are the silk proteins usually present. They are going to be there in the silkworm waste cocoons, the biomaterial. They're used for many kind of cosmetic as well as biomedical applications. And the silkworm cocoon shells. So you have the heavy fibroin chains and the light fibroin chains, and around 25% is sericin protein. So fibroin is a raw silk which is present, and it is specifically produced by the silk glands that are present in the posterior region. Sericin is the glue-like protein that is present in the mid-silk glands. So this actually helps in the cocoon to stick together, cohesion by surrounding and gluing the fibroin. So you need both fibroin and sericin together. Now, when it comes to the utilization of the silk proteins, you can do a lot of genetic, recombinations, and then see that, silk glands are altered. So you can use it for biomedical, needs. And what is it that you're going to do with them? So if you see sericin, it is used from the transgenic silkworms. You can produce basically sericin with cytokines and cytokine encapsulated polyhedra. So all of this can be used, so that solely this actually is used in the soluble fibroin free sericin at concentration. This can be detected by the electrophoresis, and then of course you use electrophoretic methods. Then the intact soluble sericin that is there is going to be incubated with ethyl alcohol. This gel can be fabricated into cream sheets or any 3D shapes, just by using mechanical strength by air drying or lyophilization, that is freeze drying. And then this is superior to collagen, can gelate in solutions of up to 96% of water. So this is, you get what you call it, sericin hydrogel, just for gelation purposes. Or you can get a sericin sponge or sericin seed. Silkworm pupae, many grainages, you're going to get silkworm pupae, especially for egg production after it is done. So 50 to 60% of the proteins are present, 25 to 35% of fats, 8 to 10% sugars, a few vitamins, minerals like calcium, phosphorus, all of this are present. So what can you do with them? You can use them as compost, nutritious material, as food. Certain parts of India have them as food. This is also good, in fact, in case, people are adaptive to be eating the pupae, at least, since there's a lot of protein, 50 to 60% of the protein, malnourishment, malnutrition, hunger will be decreased. But this is seen in India and China. So you have glycogen. So all the defatted pupae commonly used as cattle feed. Silkworm pupae are either used in different purposes. And you can use it as a poultry feed, fish feed, special oil. Pupil oil is also obtained. This can be used for the manufacture, like, for homemade soaps, used in the jute industry to soften the jute fibers. Silkworm pupil oil is nowadays used in medicines so that, like, especially those which control inflammation and anti-tumor like effects, and also it helps in treating the sinusitis, otitis, ear infection, bronchitis, asthma, any kind of inflammatory infection if you actually see. Silkworm pupae, due to the high fat content, that is around more than 30%, are used as a chrysalis oil to obtain soaps, lotions, and emulsions. Of course, you can use varnishes and dyes in the textile industry, and of course, as a natural organic fertilizer. Some countries like China, Japan, Thailand, the silkworm pupae are consumed by humans as well, and it is supposed to be a delicacy. Defatted protein used for making artificial fibers, animal feeds, manufacture of amino acids by chemical or microbiological methods. What about the silkworm moth that is present, which is actually coming out as a waste byproduct? So liquid extract from this moth can be used to treat impotence, abnormal, the gynecological as well as andrological problems. Impotence, abnormal menstruation, menopausal symptoms, especially, and then used to prepare any kind of, like, for for curing the trauma and andrological problems as such. And moth oil can be used for textile dyes and soaps. And special oil, which is around 75% of fatty oil, is obtained over here. And also, this can be used as a fodder. Moth also yields a cellular cytochrome C, which is an enzyme, uric acid, and few hormones, which can be used for pharmaceutical purposes. What about eggs? Eggs are processed into the protein extract used in pharma industry to produce medicines like hepaproteinic, hypolipidic, hypoglycemic action. And like, all the male sexual stimulator food industry it is used. So andrologically, it is a very good, like, a product as such. This extract is sold in Romania as humanophore beef product. In some countries like Bulgaria, some people believe that the silkworm eggs, if at all taken by the alcohol drinks, then they would be, like, they'll not like alcohol anymore. But it's not yet a scientifically proven fact. What about silkworm larvae? Now, this is again used pharma industry as an antibiotic, anti-diabetic medicine, or in the food industry as a supplementary nutraceutical. So supplementary, like, nutrient that gives proteins, fats, vitamins, etc. Besides this, you have a thread that is going to come from its gut, which is used for surgical purposes. So, Korean scientist Ru and others in 1997 proved that silkworms have the maximum blood glucose lowering effect. Substances that were found to be almost four blood glucose lowering substances. And major component was DNJ, which is 1-deoxynitromycin. Okay, and other nitrogen components. And what about the utility of silk? You can use silk for a lot because it has fibroin, which is almost 73.5%, and sericin around 22.28%, beside other waxes, minerals, and ash. And then you get to see that silk proteins have moisture retention, blocks UV rays. Because of this, you can use them in different cosmetics. Silk lotion has silk proteins, peptides, good moisturizer, keeps the skin soft for all types of skin. Silk cream contains almost all the 18 amino acids that are present in the silk, used to make the skin moist and nourished. And of course, it prevents the UV rays also. So it helps in the windburn, sunburn, and especially suitable for sensitive skin. And night cream, hand cream, baby cream, all of this, the night cream has different kinds of other substances such as new aloe vera, jojoba oil, and the silk amino acids and peptides. So helps in rejuvenation of the skin. Hand cream, non-greasy, gives the rough hand a small, silky, smooth, soft feel. Baby cream again can be used for the baby's delicate skin. So it shows that it is quite effective on sensitive skin also. What about the handicrafts that can be made using the silkworm waste? So silkworm cocoons or the waste cocoons can easily be converted into a full-time enterprise. So what is it that you can do? You need to have a capital, and if you have the expertise, and if you have the initiative, and then you know what kind of market demand is there, you can actually set up sale outlets, and then irrespective of any person, this can be used as a secondary source of income. What is it that you do? What are the types of handicrafts that can be prepared? So you can make pierced cocoons or cut cocoons. You can actually use them for a lot of like what do you call it, handicrafts. So they are not natural, cost effective, eco-friendly. You can make bags, you can make suits, you can make stuff out of it. Then it is good for youth, women, you name it, you can do it. And it is a very good entrepreneurship as well as skill development activity that can be done, especially in the rural areas. Gives economic stability, and at the same time, it prevents the urban migration, which is a problem for both the villages as well as the cities. So, in summary, if you see what is there, the industry leaves, cut cocoons, floss, double cocoons, black melted, flimsy, all of these are available annually for disposal, and that is around 28 tons of them. Genetic manipulation can alter the silk glands, expand. This helps in expansion of the biomedical utilities of the silk proteins. So, breeding stations, commercial grainages, you have many pupae that are being rejected. They can be used in many ways. So, silkworm pupae contain around 50 to 60% protein, 23 to 25 to 35% fats, 8 to 10% sugars, vitamins, minerals, etc. And then male silkworm moth is used in the preparation of wine. Female, the silkworm eggs have the albumin, fat, sugar, glycoproteins, B1, B2, all of it, in fact. And the spinning cocoon can be used, like the silkworm larvae. Besides the spinning of the cocoon, basically, can be used in the pharma industry. You can have anti-diabetic because they control, they are very good medicine for controlling sugar levels. And then it is used as a supplementary nutraceuticals. And then there are people in the Southeast Asian countries, in fact, wherein the silkworm pupae are it is like they prepare food out of it, and it is a delicacy. And then you have fibroin and sericin, which is the 73.5% fibroin. Sericin is around 22.28% waxes. And all of this is present in the silk. Waste cocoons can be used for the entrepreneurship and the small scale industry. This is about your lesson level. And when it comes to the economics of what is the purpose of this particular topic of sericulture? Is it going to be helpful to us? So, what are the economics of grainage? We have to understand the importance of the grainage records and the maintenance of it. In this, we get to see that the production of eggs is going to be influenced by a lot of factors. The seed cocoons that are produced in the seed areas, they should be under proper technical skilled workers and under scientific guidance, supervision. And each cost of the seed cocoons is usually fixed up by the state government and changes from time to time. Seed cocoons around 20 to 25% higher rates than the hybrid cocoons that are present. Quality of the seed cocoons is directly related to the number of disease-free layings. Since nearly around 60% of the cost of the production of the seed is the cost of the cocoons. So the egg producer, whoever it is, should concentrate that, they should be able to understand that you need good quality seed cocoons. So you need proper data from the grainage. So this will help in efficient management, of course, control of the quality as well. So what is it that we are going to see? Generally, we are going to see in the grainage, what are we supposed to maintain in the grainage. Cost of the seed cocoons, establishment charges, what are the wages that are being given, and what is the depreciation cost of the equipment. That is, equipment if you buy for in the first year, and after some time you need to pay maintenance, charges to maintain that particular equipment. And then yes, after 10 years, you can, if the equipment is redundant again, if you go for an exchange, what is the cost that is going to be involved or loss. So depreciation cost. Interest on revolving capital, you need capital for the next year as well. So you need to see that, how this dynamics and the finances should be made, seen. What is the cost of the chemicals? You're going to use acid treatment, so you're going to use different kinds of chemicals that are present, especially formaldehyde. Most, for disinfection, acid treatment, you need different kinds of acids. And then you have so many other equipment that is present. The rent of the whole drainage area, and then the electricity, because and then you need to have a freezer, you need to have an incubator, you need to have a cold storage, 5 degrees to 25 degrees, and then a centralized AC if you have the, what do you call it, since we are living in a tropical area, so you need to maintain a constant temperature, usually conducible at 25 degrees Celsius. So if you're not staying in that particular place, just to avoid this temperature fluctuation, you need a centralized AC system, at least in our country. So that electricity charges, water charges, because you need a lot of washing and all that to be done. And what are the total DFLs, that is disease-free layings produced? And utilization of the seed cocoons has a direct relationship between the to the cost of the seed production. So quality of the seed is good, then DFL is also going to be high or good. And the drainage records that we are going to see is the seed cocoon register. The register should contain information about the parental race, yield, silk quality details, and what is the bad cocoon percentage also. Have there been any mishaps in that particular grainage as such? And from where the seed rearers details, whoever is purchasing, details of the seed cocoon seller, cocoon purchase rate, weight of the cocoons purchased, and the quality of the cocoons. This details. Now, moth emergence register is one more register that is necessary. So, number of moths obtained each day, number of moths kept for pairing, percentage of the emergence. Say if 10 moths are there for emerging and only 8 emerged, what is the percentage? 80% emergence. So, number of moths left for egg laying under each combination, all of this is recorded. This will help in forecasting the production, planning for hibernation. All this data is supposed to be maintained separately for different batches. Then moth examination register. This is one more thing. Any kind, number of moths examined, type of examine conducted. Is it mass or individual? Presence of pebrine, if any, in how many batches of cocoons, if any. And then percentage of infection, whether that batch is rejected. That is important. Egg production register. Information related to the quality, quantity of the eggs laid, how many types of unfertilized eggs rejected, what is the quality fit for distribution, basically, what is the type of egg that is coming, is it a diapause egg or is it a non-diapause egg, and that is the hibernated or non-hibernated egg that is going to be laid. So all of this egg production register is maintained. Hibernation and refrigeration register, how many eggs are put in for refrigeration, how many eggs are there in the hibernation, and how many, what is the date of release, and what are the medium stages. So 15 days you need to put in say 2.5 degrees Celsius to 5 degrees, change for 20 days for all of this has to be kept. Then date of release of the eggs, temperature in the cold storage, number of moths kept in the refrigerator. When it comes to the economics, what is it that we're seeing? Industrial grainages, they're commercial entities. So inputs from different purchase. And you're not talking about only one seller. You're going to talk about different sellers as well. So all of this should be maintained, the information and inputs from the market, processed materials, DFLs that are sold to the rarer, defective cocoons also get the returns basically. So of course, if not a profit, at least you're not going to, it's going to be a break even, if not that goes into negative. And so you need to know the cost of the production of egg laying and to and according to the unit as such. So cost of establishment, operating a commercial grainage, you need to have capital investment on the land, on the building, the cold storage, non-recurring expenditure, that is your equipment, furniture, fixture, vehicles, and these are all one-time investment. Recurring expenditure is your established charges, that is so recurring an investment is basically cost of chemicals purchase, stationery, labor wages, electricity, diesel, water charges, etc. So you're going to actually have the cost of production in the switch on capital investment, depreciation, and diesel, water charges, buildings, etc. And the depreciation is calculated based on the longevity of the building and then the cold storage, equipment, furniture, vehicles. So cost, longevity, depreciation value is X by Y. Your basic calculation economics. In any case, one must be sure that, and of course, you have to have all the specifics details stored. Receipts should be there. Your DFLs at a lower cost utilizing all the latest teaching equipment will actually help you. So one should see that, you have to reduce the cost of production. Quality of egg also determines the reputation, stability of the grainage. Utilization of the seed cocoon has a direct relationship. If the quality of the seed cocoon is good, then DFL is going to be high. So you have capital investment amount. This is how your receipt is going to be there. And also you need to see put in indent and put maintain all these bills as such. Non-recurring expenditure, recurring expenditure, all of this is recurring expenditure, receipts. Sale of defective cocoons also will give you a amount. Cost of production of one egg laying is calculated from all of this listed together. And then you see the capital investment, non-recurring. So cost of production of one laying is C plus D plus E minus F by number of disease-free layings produced. This is the one DFL cost. What is C? Initial investment plus depreciation cost plus recurring expenditure minus the receipts is the number of DFLs, per number of DFL is your one DFL cost. Now, when we have to summarize this particular lesson, we get to see that when it is the economics of your grainage or economics of seed production, seed selling, you're going to see that the seed cocoons, they are going to be produced only in areas under specific guidance and supervision. Cost of the seed cocoons is fixed by the state government and from time to time it might vary. And seed cocoons are around 25% more expensive than the hybrid cocoons, and maintenance of different kinds of quantity, records. Like I told you, it's all the different kinds of records such as your seed cocoon register, moth emergence, moth examination register, egg production register, hibernation and registration, refrigeration register, and of course your capital investment on the land, building, and cold storage, and non-recurring expenditure, which is your grainage equipment, furniture, fixtures, and the vehicles that are involved. And of course, you have the interest on the items of A and B, calculation of depreciation, recurring expenditure that is also calculated. In the recurring expenditure, you have the establishment charges, electricity, water, diesel, maintenance of the vehicles, miscellaneous items, egg sheets cost, stationery, printing, cost of the seed cocoons, cost of the chemicals, labor wages, all of this involved. And then you're going to calculate one disease-free laying through this. So grainage aim is to produce the DFLs at an offer cost. So you need to maintain all of this for planning and timely activity. And it is to produce the DFLs at an offer able cost. That is 60% of the cost of production of the seed goes to the cost of the cocoons. Investment, recurring, non-recurring, they are going to calculate. Through this, you're going to calculate the cost of the production of eggs. And then you should aim at the quality of the eggs than rather than on the reduction of the cost production, but see that you get good quality eggs which will actually eventually lead to profitable income. So this is all about sericulture. So you have different kinds of questions over here. Please follow the model questions that are given at the end of this particular book so that you will be able to score well and be able to understand the whole concept of sericulture. Thank you. It is not only about scoring, but it is also about the understanding of the sericulture industry for you to, if at all necessary, choose this as a career option, because it is an industry as such, and it is quite profitable as well. Thank you so much for your valuable time, and at the same time, all the best for your exams. If at all there are any doubts, you can feel free to ask. And that is all about sericulture. Thank you.